Today we're going to make the next step. We've been talking about ratios. Now we're going to show you a new way to display the ratios, which is called a ratio table. A ratio table is just a visual depiction of pairs of numbers that form equivalent ratios. All ratio tables have both additive and multiplicative properties as you look at them. So ratio tables can be looked at from either the additive or multiplicative nature. Let's do the additive first, because this is the one I actually kind of prefer. It's the way I normally will look at these tables. In an additive aspect, all you're doing, you're taking an initial value of the ratio. That is normally going to be your first entry. Sometimes they'll start off at not the initial one. You can always go back to the initial entry by simplifying the value. In an additive table, all I'm doing is taking the value that I'm starting with, and I'm going to add that value to each successive row. So in this case, my first column starts with 3. I'm going to add 3 on this side. So 3 plus 3 is 6. On this side, my first value is 11. So I'm going to add 11. So on this side, I add 11. So 11 plus 11 gives me 22. So back on this side, I'm going up by 3. So I'm going to add 3 again because I add that initial value each time. So 6 plus 3 gives me 9. On this side, I'm adding it by 11s. So now I go 22 plus 11 gives me 33. Now, majorly important thing, guys. I have just shown you how you're going to show your work on tables. You're going to put on the side the arrow showing what you're going up by on each of the two values, if you're looking at it from an additive aspect. Does that make sense? Okay? What this allows us, Ms. McShannon and I, as teachers to do is if you make a math error on the table, we can say, oh, she understood the concept, she just made a math error. And then we can still give you half credit. If there's no work shown, you make a math error, guess what? You got the whole thing wrong. Because you mess up one entry, especially early in the table, every entry is wrong, meaning you get 0 credit. So this is how you show your work, so you can prove to us that you understood what you're doing, you just made a mistake. Kaylee? Which part are you not understanding? Amazing, when you look at the table and see what I'm doing, you can actually understand. It's okay, Kaylee, we understand. Okay, now that we have developed that pattern, we can actually just finish out our table. So if I'm adding 3 on this side, after 9 it would be 12, then it would be 15, then it would be, make sense? On this side I'm going up by 11, so after 33 it's going to become then, make sense? So we want to see the work for the first 2, but we're not going to make it right every time because that'd get really old. But 2 times will show us that you understand the pattern. Now, the other way I can look at these tables is what we call a multiplicative nature. So it's the same deal. I'm still starting with this initial value. In this case, it's now 2 to 5. Here's where the multiplicative is different. In the multiplicative value, what I'm going to say is, okay, I'm going to take this initial value up here, and I'm going to multiply it by 2 in order to get my next one. So what's 2 times 2? What's 5 times 2? Okay? Then I go back to my initial value again. I say, okay, now for my next entry, I'm going to take my initial value times 3. So what's 2 times 3? 6. 5 times 3. See how that works? Okay, then I go back to my initial value. Now I'm going to go to the 4th row. So 2 times 4 is 8. 5 times 4. Then I'm going to do the next value. So it's 5. 2 times 5 is 5 times 5. 2 times 6. 5 times 6. Okay? So here is your work on the multiplicative value, showing from your line that I'm starting at that initial value, going to whichever line I'm doing, and how much I'm multiplying by. Times 2, Then my next line went times 3. That's showing your work. Okay? Now, here's why I say you can do these tables and look at them either way. So even though this one's labeled additive, watch what happens if I look at it multiplicatively. Excuse me. 3 times 2 is 11 times 2 is 22. 3 times 3 is 11 times 3 is, see what I mean? On this side, I could have said, okay, I'm going up by 2. 2 plus 2 is 4 plus 2, 6 plus 2. See it? 5 plus 5 is, plus 5 is 15, plus 5 is. So either table, I can look at it either way. So why are we showing you both? Because we like to give you options, number one. Number two, some of you are going to be more comfortable with additive. Some of you will be more comfortable with multiplicative. Whichever way you want to do it is fine. They asked me last class what's my preference. I prefer additive because in additive, I've always got my baseline right here. And you'll see this when we get to showing you guys the division algorithm where you're building your times tables for bigger numbers. Literally, all I got to do is now take this, I add it to this value, and I get my next one. Take this, add it to the 55, I get my 66. So it's like I've got my little cheat sheet right there with that initial number that I'm adding every single time. Avi?
Does it always have the initial number on the top, or are we going to be doing like...
They don't always. Sometimes you'll see it where the initial number is not in simplified form, and then you would simplify that to figure out what that initial ratio would be. Yes, Emma? Uh-huh. You don't have to. And this is the one, especially multiplicative, where I said we normally going to see larger ranges on this. Normally what's going to happen is, excuse me, you're going to see much bigger numbers, and it'll be skips. So it doesn't have to go 2, 4, 6. It can go 2, 12, 200. Times 3. Yeah, you don't have to go up sequentially. You can do skips. So I could do 2 times 2, then 2 times 3, then 2 times 10, then 2 times 20. Yeah, whatever I'm multiplying on this side, I'm doing both those values. Does that answer your question? Okay. Now, sometimes they're going to give you a table with missing pieces. You have to look at it in either of these two manners in order to figure out what's missing. So, for example, on this first one, who sees some patterns that we can use to start filling in those missing pieces? Avi, I saw your hand first. So on this first column, we're going up by 3s. She sees that right away because they're all 3 together, right? So to fill in my missing values, I'd say, okay, what number is 3 before 9? Or 3 before 12? So I gave it to you. 9. What number is 3 before that? The number 3 before that? Make sense? Okay, so what's happening on the other side? Mateo? Plus 17. How did you get that? Okay, so he just did subtraction. He said, okay, 51. I subtract that 34. What did I get? 17. And then you can double check it because what's 17 plus 17? 34. So it works both ways, right? So this is the one that's a good example of why I prefer the additive value. Because now that I have my initial value, watch. All I have to do is I go, okay, my next value here, I go 7 plus 1 is 8. 1 plus 5 is 6. So by looking at additively, knowing that 17 is that number I'm adding, I've got the number up here to start with, and I'm just adding that now to each entry. So I do that the next time as well, right? 7 plus 5 is 12, carry the 1, so that makes that a 2. 2 plus 8 is 10, 102. Pretty easy? JJ? Multiplication 1 is just literally just saying, whatever my initial value is, I multiply both of them by the same number, and that gives me an entry line. So if I take 2, I multiply it by 10. 2 times 10 is 20. Then I also have to multiply 5 by 10. So 5 by times 10 is 5 times 10. So there's another entry. So I mean, hopefully that helps explain too. Do I have to do them all in order? No, I can go 12 to 20. That's the only advantage is multiplicative. I don't have to have all those values in between. Multiplicative allows me to make jumps. I just got to make sure I'm doing both of them by the same number. Wesley? Yep. Yeah, most of them, because you can look at them either way, unless they specifically tell you how you have to look at it, you can do either one and it's fine. Okay, let's look at some examples to try to help you guys understand how this works, okay? So, first one, to make paper mache, the art teacher mixes flour and water. For every 2 cups of water, she needs to mix in 3 cups of flour to make the paste. Find equivalent ratios for the ratio relationship 2 cups of water to 3 cups of flour. Represent the equivalent ratios in the table below. So there's 2 parts. We need to find the equivalent ratios, and we're going to put them in the table. Funny enough, we can actually do both at the same time. So our first problem here, we're comparing water to flour. What's my first initial entry? Rosana? Awesome. 2 and 3. So what would my next entry be? Emily? Okay. And for 3 it would be? How did you get those? Okay, so she's looking at it from an additive perspective. So to show my work, I just put that on the side. So I said, okay, on this side I'm adding 2, on this side I'm adding 3, meaning my next entry is 6 and 9, correct? Now that I've shown my work twice, you don't have to write that on the sides. We're not that mean. We're not going to make you do it every time. But we do need to establish that you see the pattern. So now I can finish it out. So then I go 8, 10. Then I go 12, 15. Now, you guys may notice something. If I'm doing additive values, which way do I tend to fill the table out? I go down, don't I? Because it's like, okay, I've established this pattern. I'm going to continue it for all the spaces. Then I go to the other side, and I continue that pattern for all the spaces. Make sense? You're going to see in a second how this changes. Okay, go ahead and turn the page. Now, I will say, it's actually okay on these tables. Most of the time, we're going to do them up and down vertically, but it's actually okay to do them horizontally as well. So if your space dictates that a horizontal table would be better, there's nothing wrong with that. Okay? On this one, what we're going to say is, Javier has a new job designing his websites. He's paid at a rate of $700 for every 3 pages of web content that he builds. Create a ratio table, so there's a task, to show the total amount of money Javier has earned in ratio to the number of pages he has built. So what is my first entry going to be? 703. Love the fact that Emily said that, because that is what we have taught you. That is what is correct. Do what? Oh, that was Avi? Sorry. It's the problem with masks. Okay. Now I'm even happier that Avi said it, because she was wrong. Did you guys read the table? Emma? 3 to 700. Why is that wrong? So this is one of the things I really don't like about the Engage New York curriculum, guys. We have taught you the proper way to do it. The proper way is they've written it as 703. My table should also be written that way. For some unknown reason, they decided to flip it. So this is not Miss McShann and I trying to fool you, but if you pay attention, I'm sorry, it's all Miss McShann. So it wasn't both of us, it's all Miss McShann trying to fool you. No, it's actually Engage New York. I don't know why they do this, but if you are paying attention, you should have had the numbers in the right spot. So I'm sure Avi would have realized, even though she said it correctly as 703 when she went to put it in, she'd have been like, no, it's not 700 pages for $3. That's not very good, right? That would be terrible. That would be a major scam. Okay, now, here's where we did the last one is additive, so I'm going to make this one a multiplicative. So what we're going to do is take this initial value, and we're going to multiply by 2. So 2 times 3 is 6. 700 times 2 is 1,400. Then I'm going to go times 3. So notice how for showing my work, my arrow starts at the initial value, show what I'm multiplying by, and then to which column I'm doing it. So again, go back to the initial, show what I'm multiplying by, this new column. Then I do 3 times 3 is 9. 700 times 3, 2,100. Now we do times 4. 3 times 4, 12. 700 times 4, 3 times 5, 700 times 5, 3 times 6, 700 times 6, 3 times 7, 700 times 7, 3 times 8, 700 times 8. I know I go a little fast. I will pause just for you guys. Okay, now we need to actually look at the question that is asked. Javier is saving up to purchase a used car that costs $4,200. How many web pages will Javier need to build before he can pay for the car? So there's our question. How many web pages does he need in order to earn $4,200? What do you think, Emma? How did you get that?
I looked at our table and it says $1,200 and I looked up and I had 8.
Awesome. And guys, what Emma just did, this is the advantage to the ratio table. Is this table hard to build? Not really. It's actually pretty easy, right? But once it's built, now if they ask me a follow-on question, just like Emma said, all I had to do is look at the table, I find the 4,200, and I know how many pages I need to build. Javier needs to build 18 pages. Again, we're going to see this in several lessons. I think it's actually the next module where we're going to introduce you to the division algorithm. This is actually an amazing thing because you can do multi-digit division relatively easy by building a simple ratio table. You basically build yourself a cheat sheet. And you're going to get enough practice to realize building these cheat sheets is actually really easy. Right? Uh-oh. See that, Miss McShann?
What?
Biden has the hiccups. Oh, nothing. Don't worry about it. It's all good. Well, you actually gave me perfect timing for that. Because here's your chance to do some work alone, guys. So we want you guys to go ahead and do work together. Do exercise 1. Show us that you can build these tables and understand them.
Kaylee, would you rather Mr. Moore do it? Because I'm totally fine with that. All right, let's look at this one. It's not the same, I'm sorry. All right, so spraying plants with cornmeal juice is a natural way to prevent fungal growth on the plants. It is made by soaking cornmeal in water, using 2 cups of cornmeal for every 9 gallons of water. Complete the ratio table to answer the questions that follow. So what are we starting with in our table? What ratio did they give us for cornmeal to water, Avi? And how many gallons of water? Any questions about that? All right, so what would come next in my table, and how did you get it? I did. Okay, so I add 2 and I get, and then I add 9 and I get. Does everybody agree with that? So he did the additive table, and that is fine. So again, we're going to add 2 and we get, and we add 9 and we get. So if I continue, next would be, and last, and. Any questions about how to build the table? This was easy peasy, right? All right, so looking at the table, A says how many cups of cornmeal should be added to 45 gallons of water. So I find my water, I find 45, and how many cups of cornmeal do I need, Emma? 10. I need 10 cups of cornmeal. Remember, if it is a word problem, it needs word answers. Got it? B says Paul only has 8 cups of cornmeal. How many gallons of water should he add if he wants to make as much cornmeal juice as he can? So I find cornmeal, circle my 8. How many gallons of water do I need?
36.
36 gallons of water. Now, lots of people had trouble with C. So let's look at it. 2 to 9 is already in simplest form, yes? If I simplify 4 to 18, what does that simplify to? 2 to 9. If I simplify 6 to 27, what does that simplify to? 2 to 9. What about 8 to 36? So when it asks you, what can you say about the values of the ratios in the table, what can we say? They are all equal to 2 to 9. But what is that word I'm thinking of that we've used a lot this year? Kind of. Somebody said it over here. Who was it? Equivalent. They are all equivalent to 2 to 9. Any questions about that? All right, the next one on the next page is tricky, so I want you to mark your text carefully and read carefully. We're going to give you until lunch and then a few minutes after lunch to work this one out. Any questions? All right, get started.
Okay, on this one, there is some comprehension that is required on this one. So let's mark our text. That's going to help us. James is setting up a fish tank. He's buying a big goldfish that typically grows to be 12 inches long. It is recommended that there be 1 gallon of water for every inch of fish length in the tank. What is the recommended ratio of gallons of water per fully grown fish in the tank? So there's our first question. Once we have that, we can then complete the ratio table to help answer the following questions. So they want us to do that part first. So what is our ratio? I know several of you are struggling on this one. So how many fish am I going to put in the tank to start? Rosena? 1. How many gallons of water do I need for that 1 fish? 12. Emma? 12. Okay, why? Because it's 12 inches, but I need 1 inch for every inch of fish.
1 gallon.
1 gallon, thank you. 1 gallon for every inch of fish. So now, what's my next entry going to be, JJ? How did you get that? Okay, so you're looking at it as additive. Don't forget to show your work, guys. So then my next entry would be,
Who was singing over there? Please stop.
I think it was Kaylee. What's that?
That's okay.
That's okay. Yes, because I have such a huge following on YouTube. Actually, it'd be interesting if there's anyone from like not in my classes that ever listen to these videos. I wonder what they think. Okay, part A. What size tank in gallons is needed for James to have 5 full-grown fish? So here's the advantage of the table. Now that I've got the table built, it's a quick reference chart for all of these follow-on questions. Gabe, what do you got? 60. Thank you. He needs 60 gallons of water. Okay. How many full-grown fish can live in a 60-gallon tank? What do you think, Kendall? 3? Why'd you say only 3? Why not 4? Good. So if you put down 4, you're one of our fish killers. Do we have any fish killers in here? Mary? Mary's killing the fish. She's putting 4 in there. They all die. What can you say about the values of the ratios in the table? Yes? Awesome. You used all the correct terminology. They are all equivalent to 1 to 12. Love the fact you threw the equivalent in there as well. That was really the word we were looking for. Good job using your math terminology. Any questions on that page, guys? Okay, let's go ahead and turn the page. Here is your first page of homework. So, a quick side note. How many homework assignments have we had so far? 5. So far, Mr. Chan and I have been pretty nice. If you didn't do all the work, but you got really close, we gave you credit. That stops today. This is the assignment that historically half of my class only gets 50% on because they've got to pay attention to the directions, especially when I pointed out to you guys that this is what we're expecting. So let's read the directions. Assume each of the following represents a table of equivalent ratios. Fill in the missing values, then choose one of the tables and create a real-world context for the ratios shown in the table. So how many things do we have to do on this for our homework? More than one. The first one is what? No, the first thing we have to do is fill in the missing values. So I have to finish all 3 of the tables, filling in the missing values for all 3. What is the second thing that we have to do? Let's say that. What does that mean? You're right. What kind of problem? From the world. So we need to make a story problem. You're making a real-world story problem for one of the 3 tables. I'll give you a hint. You're probably going to want to make it about the initial value. Technically, you can use any value in there, but it'll be easier to make the story off of the initial value. So once you have filled out the tables, pick one of them, create a story problem for it. Make sense? Any questions on what you have to do for this piece of the homework? 9? Okay. Let's turn the page. Let's do lesson 10. Well, I did live in Germany for 10 years.
I am part German.
I know, that's why I mentioned that. technically, I'm also part German as well. My mother's maiden name is Ackerman, so strong German. Okay, imagine you're making a fruit salad. Every quart of blueberries you add, you would put in 3 quarts of strawberries.
You're really getting tongue-tied today.
I am. Create 3 ratio tables, so there's a task, that show the amounts of blueberries and strawberries you would use if you need to make fruit salad for greater numbers of people. Table 1 should contain amounts where you have added fewer than 10 quarts of blueberries to the salad. Table 2 should contain amounts of blueberries between and including 10 and 50 quarts. Table 3 should contain amounts of blueberries greater than or equal to 100 quarts. So they've given us these values to drive how we build the tables. So, Mateo, what should I put for our first table? What would I do if I'm going to add fewer than 10 quarts of blueberries? Where do you think we should start? Are you even on the right page? No. Oh. So all that marking in the text I've just done that you didn't follow. Let's find someone that's actually where they're supposed to be. Wesley, help us out. Okay, so what number would you use for the blueberries? What's a good one to start?
What ratio did they give you?
It says for every quart of blueberries, you put in 3 quarts of strawberries. What numbers are associated with that?
What does that bring me?
Does everybody see that? Anybody not see that? The dead silence when I asked that question was really disturbing. Yes? You don't see it? It's right here. For every quart of blueberries, I add 3 quarts of strawberries. So if I start at 1 to 3, what would my next entry be? How did you get that? So you're doing multiplicative? I'm going to change. I'm going to do additive on the first one because this is lower numbers. So I'm adding 1, I'm adding 3, right? So again, I'm going to add 1, gives me 3. I'm going to add 3, gives me 9. So I know I'm just adding 1, so that makes 1, 2, 3, 4, 5. Adding 3, 3, 6, 9, 12, 15. Does that make sense? Okay, for table 2, they said, now I have to have from 10 to 50 quarts of blueberries. So where's this one going to start at? I have to start with 10 quarts of blueberries. So how many quarts of strawberries would that be? Be what?
For every 1 is 3. That means for every 10 it's... There we go.
Okay, so what did we just do? We just used a multiplicative value, really. We took our initial one, we multiplied both of them by 10, right? So now that we're doing bigger numbers, now's where we're going to do the multiplicative. So now I'm going to do times 2. 10 times 2 gives me 20. Make sure that looks like a 2. 30 times 2 gives me 60. Then I'm going to do times 3. It's going to give me 30, 90. Then I do times 4, 40, 120. Then times 5, 50, and 150. Okay? Then our third table, what did they say we need to do? Leah? It's right here. You also have it in your book. Greater than? So if I have 100 quarts here, what's my strawberries going to be? Good job, Cannon. Does everybody else see that? Right? So 200 is going to be 600. So again, because we're doing big numbers, I'm going to do multiplicative. So that's times 2. Then we're going to do times 3. It's going to give us 300, 900, then 400, 1,200, 500, 1,500. Are you guys starting to see how to build these tables? Pretty easy? Good. Okay, Aaron. Oh, no, I left the answers there. Hopefully they didn't see it. Okay, guys. Now, the following tables were made incorrectly. Find the mistakes that were made, create the correct ratio table, and state the ratio that was used to make the correct ratio table. So 3 things that we have to do. Okay, Aaron, since you're so good at these, what is a mistake in our table for part A? Yep. Guys, everybody look at the table, see if you can find the mistake. No, we're letting Aaron. Okay, what else? If you see it, raise your hand.
Oh, wait, no.
You got it?
Yeah, there's 2 things that are multiplied by 7, but it's not.
Say what?
What?
I don't know. He said there's 2 things that are multiplied by 7. There's only one entry. It's 52. I don't know what he's saying. We have a lot of hands here, Aaron. You want help? Do what?
I have no idea.
Okay, Ryden? But they added the same amount every time, right? So that's okay. It doesn't necessarily have to be that number, but if I'm adding the same amount, I'm okay. As long as I do the same thing on the other side. Did they add the same amount on the other side each time? Madison? What is it? So I think Aaron saw it because that was kind of what he said was the 7 row. He just wasn't able to verbalize what the problem was. Okay? So basically I'll give you a hint, guys. Even though it said the third thing was state the ratio, if I go to the initial ratio and simplify it, it's going to help me. So if I do 3 to 24 and simplify, what does that become? What can I divide 3 and 24 by? Sophie? I can divide 3 by 8?
You're on the right track.
She just did the math in her head already. She's saying the answer. Divide them both by 3. So the actual ratio is 1 to 8. So if you actually go to the correct ratio, guys, and do the third thing first, it will help you find the mistake and fill out the correct table. So if I were you to do this, I would actually go in reverse order. I'd find the correct ratio, build the ratio table, because then I can go 1 to 8, but they started at 3, but we can do that, right? 324, 5, 40. So here I'm adding 2. Here I'm adding 16. So then I get 7, 56, 9, 72. And then you can say, oh, wait, here's my mistake. So you've done all 3 parts. Now the good news is we're out of time, so you don't have to actually do that again. We were going to make you do the rest of this page, but we do want to cover the last of the homework. So in the homework, go to page 41. Here's the other part of your homework. Again, these are not multiple choice. You have to do every problem. There's 2 parts to part number 1. There's 3 parts to number 2. Don't come and just circle a number. That's not correct. On the first one, create a ratio table using lemon juice and a water ratio of 1 to 3. Then they say it's 36 cups of water. Guys, hint, multiplicative values. So start with 1 to 3, then use multiplicative. Otherwise, you're going to have a very long table. It's got to have 12 entries. You don't need that many. Technically, you can do it in 2. Second, part B. We haven't talked about this much, so here is your answer. How is the value of the ratio used to create the table? The value is multiplied by the same number for the next entry. So that initial value multiplied by the same number. So that's the answer. If you want to copy it down, I already did 20% of your homework for this page. 2, part A. What ratio was used to create the table? Support your answer. In other words, show your initial value, write that as a ratio, and show us simplifying it. That's going to be your work on that one. Part B, how's the values in each row related? Rows go left and right, guys. So it's saying, how do I go 12 to 3, 20 to 5? What's that relationship in here? Then the final one is, how are the values in each column related? In other words, as I'm going down, because columns go up and down, what's the change as I'm going down? So find those values. Any questions on your homework? Sean? So in other words, as I'm changing from 12 to 20 to 28 to 36, what's happening? Do what? By how much? As I go from 3 to 5 to 7 to 9, how are they changing? By how much? In other words, what I'm saying, look at it. I'll give you a hint. If you're looking up and down, look for the additive value. If you're going left and right, look for the multiplicative value. Yes? Okay. I said you need to make a table. Make sure you label your table, because we haven't really made tables yet. But you'll notice every table has a label to it, so make sure you have a label on your table. You need to have at least 2 entries. You have to have your initial value, 1 to 3, and then you have to have 36 for the water. Show me what the value for the lemon is, lemon juice. That's the minimum. If you want to do a whole table and go all the way from from 3 to 36, you can do that. But that's going to be a much bigger table than if you use multiplicative value. Yes? Come again?
If you want to work across, that's fine.
Okay. So you guys